Hello everyone, my name is KOKNE. I am a data science and business analytics intern at the Spark Foundation. This is my second task, which is to make prediction using unsupervised machine learning. In this task, I will apply k-means clustering algorithm that aims to group similar data points together based on their similarity and represent it visually. So let's get started. First, I have import useful libraries such as pandas, numpy, matplotlib, seaborn, import k-means from the sklearn cluster, and also import the warnings to avoid future warnings. Now I have loaded the dataset and it is stored in the data variable. Then I have removed irrelevant data from the dataset which are not useful for the data analysis, and I have removed the ID column. Now we can see that iris dataset contains 5 attributes, that is sepal length, sepal width, petal length, petal width, which are flower measurement, and 3 species of the iris flower. Now start the exploratory data analysis. First I have checked the shape of the dataset. It contains 150 rows and 5 columns. Then check the shape of the check the data type of the data set, and it contains only one categorical variable and other 4 are numeric variables. Then check the summary of the data set using the describe function. This shows the statistical information and gives good picture of the distribution of the data. Then check the number of unique values present in our dataset. Also check there is any missing value in our dataset or not, and this shows the no missing value. Now start the data visualization part. We can see that count plot of the species, and it shows the equal number of sample of the species. Then check the univariate plot using the histogram of the sepal measurement and petal measurement. Then check any outlier present in our dataset or not using the box plot, and this box plot shows the species setosa as the smallest feature and less distributed with some outliers. Then check the violin plot of the petal length, and violin plot combines the benefits of the box plot and histogram. Then check the relationship between the each pair of the feature using the pair plot, and it shows the species setosa is separate from other 2 species. Then check the multivariate plot using the scatter matrix, and it shows the diagonal grouping of some pair attributes. It suggests the high correlation. Then also compare the sepal measurement using the scatter plot, and also similarly check the relationship or comparison between the petal measurement using the scatter plot. Now check the correlation between the various variables using the heat map, and this heat map shows the highest correlation between the sepal length and petal width, and also good correlation between petal width and petal length. From this EDA part, we can conclude that petal length properly differentiate the classes, hence feature importance of the petal length should be more. Now start the k-means clustering algorithm. For that, we extract the important feature from the data set and store it in the x variable. Then start to find the optimal k value for clustering data using the elbow method. To find the optimal k value, for that first create empty list of the WCSS, that is sum of squared distance between each point and centroid. Then create a for loop to get the best number of cluster, and I have stored it in the k-means variable. Then apply it for the x variable where values have been stored. Then I have created a elbow plot which is graphical representation of finding the optimal k in the k-means clustering. In the elbow method, we are actually varying the number of clusters k from 1 to 10. When we plot the WCSS, the k value, the plot looks like elbow. Now we can see that this chart shows the after point 3 all the points are constant and create a elbow shape. That is our k value or optimal value of the cluster. After that, I have built k-means clustering model and apply it for a k-means and predict the value y k-means. Now I have visualized the cluster using the scatter plot. For that, use the petal measurement because petal measurement properly differentiate the classes, and we can see that there are 3 clusters: iris setosa in yellow color or orange color, then iris versicolor in green color, and cluster 3 versenica in the purple color, and center of each cluster is shown in the black color. We can also see the 3D scatter plot of these 3 clusters. In this way, I have built successfully k-means clustering model and predict the optimal value of the cluster and represent it visually using the scatter plot and 3D plot. Thank you.